Okay, the last three examples, rather than finding the area of the individual regions and then adding them, we're trying to find the area of the shaded region, and so we're going to have to find areas of the individual parts and then subtract them, okay? So this first example here, we want to find the area of the rectangle first and subtract then the area of that semicircle. Okay, so that rectangle, just base times height. So we're going to take 50 times 30. And so the area of the rectangle, if that semicircle had not been cut out, would be 1,500 square feet. Okay, but we've got to find the area of this semicircle and take it away. The diameter of that circle is 30. So that radius, whoa, that radius is 15. Okay. Half of 225 is 112 and a half. So we've got 112 and a half pi square feet. All right, and again, to find the total area of the shaded region now, we're taking the bigger shape minus that shape that is cut out of it. Okay, so this we've got a semicircle, so we have an exact answer. Okay, not multiplying pi by the 112.5, but if we do that and then take that away from 1,500, we get about 1,148.14 square feet. Okay. Okay, example 7 here. Again, I see a rectangle. That's my big shape. And then I see a triangle. That's my shape that I'm cutting out of the rectangle. Okay. Rectangle is base times height. So we take 5 times 6 for an area of 30 square meters. Okay. Now looking at this triangle, I can tell that my base is 6, but I don't have a height. Okay. The nice thing is, since both of those sides that are labeled there are 4, that means this is an isosceles triangle. Okay, and why that is helpful, the height here, not only does it bisect the base, but it's also perpendicular to the base. Okay, so we can use the Pythagorean theorem here to find the height of this triangle. Okay, so that's 9 plus h squared equals 16, which means that h squared is 7. So the height of this triangle is the square root of 7. Okay, so now we're going to go back and we're going to find the area of this triangle. Our base is 6. That height we determined was the square root of 7. So the area of that triangle is 3 square roots of 7 square meters. Okay. Here we're taking the area of the rectangle and we're taking away the area of that triangle. Okay. Now here, this is an exact answer, again, because we've got another irrational number. Okay. But if we go ahead and take 3 times the square root of 7 and take that away from 30, we get about 22.06 square meters. Okay. Example 8, we're looking at a parallelogram. Okay, that's the big shape. And then this inside shape, that cutout portion, is actually a kite. Okay, so parallelogram is just like a rectangle. We take base times height. Base is 14, height is 9. So the area of that parallelogram without the kite cut out of it is 126 square feet. Okay. Yikes, that got really big. Okay. Area of a kite. We multiply the lengths of the 2 diagonals and then divide by 2. Okay. So one diagonal is the same as the width of this parallelogram, which is 14. The other diagonal is the height of that parallelogram, which was 9. So we are going to take 14 times 9 and divide it by 2. And that gets me an area of 63 square feet for that kite. Okay, and again, we take the big shape minus the little shape. And that tells me that the area of that shaded region is 63 square feet.